Hello friends, in this lecture we have to see about GM counter and we will cover the points like its principle, construction and working. So this GM counter means Geiger-Müller counter, and this Geiger and Müller are the name of scientists who invented this GM counter. And this GM counter is a device that used to detect the ionizing radiations, and the ionizing radiations are like beta particles, gamma particles, etc. And this GM counter is also used to measure the ionizing radiations. So the ionizing radiations are the radiations which are resulting from the disintegration of radioactive materials, and these ionizing radiations cannot be sensed by humans directly, but this doesn't mean that these radiations cannot affect us. Its presence affects human both directly as well as indirectly. So for that, detectors are necessary to detect the radiations. Again, one property is there: when radiation is passed through gases, then this radiation ionize the gas, and using this property, or we can use this property to detect the radiations. And this property is the principle of this GM counter tube. So see this figure here. This outer cylindrical part is called as GM tube, and inside this tube a hollow metal case is there. This metal case is generally made up of a aluminium, and this acts as a cathode here. Again, along the axis of this metal case, a fine metal wire of tungsten is placed. This metal wire acts as an anode here, and this cathode and anode is separated by the ebonite plugs, that is, it is an insulator. Now one end of this tube is made up of a mica, that is, this is a mica, and this mica is a window for the incoming radiations inside this GM tube. Along this cathode and anode, a external circuit is made, and using this we apply a high voltage along this cathode and anode, and this voltage is about 1000 volt to 2000 volt or up to 3000 volt also. Again, here amplifier is there and counter is also there. Now this tube is firstly evacuated and then filled with the gases or the mixture of gases, and the mixture of the gases contains 90% of argon and 10% of ethyl alcohol vapor, and this mixture is used here. So this is all about the construction of GM counter tube. Now let us see about its working. And for working mechanics, see here, this is a mica window which is entry for the incoming radiations in the GM tube. So when radiations are entering inside the counter, the gases atom which are present in the tube gets ionized. As we know, ionization means the process by which atom or molecules acquire a negative or positive charge by gaining or losing electrons, and in that case the charged atom or molecule is called as an ion. Here, when radiation is incident on the gas atom, then electron from the atom loses from the atom and forming cations and anions. So when we apply a voltage along this cathode and anode using this circuit, then the electron which is loses from the atom is moved towards this anode, that is moved towards a fine metal wire of tungsten, and the positive ion moved towards the hollow metal case, that is towards the cathode, and hence due to this a current pulse is generated along this circuit, and due to this current pulse a voltage drop or voltage pulse of the order of 10 microvolt is produced. As we know, V is equal to IR. So now voltage pulse is then amplified by this amplifier, and the signal is applied to this counter. This counter counts the signal for each incoming radiations, as this each incoming radiations produce a pulse of the current in this circuit. So this is about the working of GM counter. And again here, if we apply a voltage high enough, then the ions produced a secondary avalanche that causes a current pulse. So now see this figure. This figure is a plot of count per minute versus voltage. Here for voltage up to 1000 volt, there is no any count per minute. That is, there is no discharge. If we apply a voltage beyond this 1000 volt up to 1200 volt, then in this region the count per minute increases linearly with voltage or applied voltage, and this region is called as proportional region. Now beyond the 1200 voltage up to 1500 voltage, count per minute remains almost constant with increasing voltage, and this region is called as a plateau region. Also you can call this as a operating region and or Geiger region. Now again, if we increase the voltage, then count per minute increases rapidly. That is, there is a continuous discharge will takes place. So this is the characteristic of GM counter. This plateau region is most useful for the working of the GM counter. Using this GM tube, one can count 500 particles per second. But disadvantages is there, and this disadvantages of counter is the dead time. Means dead time is the time taken by the GM counter to recover between counts, and it is up about 200 microsecond. Suppose if incident radiation density is high, then in that case GM counter will not have time to recover, and due to this some radiations may not be counted, and this is the main drawback of this GM counter. So this is all about the GM counter. Thank you.